Hello and welcome to another bonus lesson. In those segments, we are introducing tools without any deeper context. Quick pill of knowledge, so we hope you'll enjoy them as well. Today we are touching on the subject of caustics. If you haven't encountered it yet, we'll show you how to use it in an easy way, so let's immediately get at it with a very brief introduction first. So, caustic is a term typically used in CGI circles to describe a type of reflection or refraction of light by a curved surface. Usually, we need some non-flat, non-straight surface, at least not completely flat, like, for example, glass balls or some glass jug. We see here that the light goes through the glass, gets refracted, and we get this specific pattern. Some of this light is enhanced and some are reduced, and this is what we call caustics. Caustics can be both refractive when the light passes through the object and reflective when light reflects off an object. A good example is when at sunset we have some reflections on the facade of the building coming from the windows of another building. We usually see some strengthened elements and reduced ones. That's because glass is rarely perfectly flat. We have some small distortions of the pane of the glass, and that's why the reflection of the sun on another facade is quite varied. For an artist, it might be tempting to use caustic effects whenever we have a body of water in our scenes. We all probably recognize this caustic pattern at the bottom of a water reservoir. We associate it with a very clean water and a sunny day. It generally causes a pleasant response, and that's something we can really take advantage of in production. And unfortunately, I think many artists don't, or at least not in a physically correct way. That's because until recently, it was very time-consuming when it comes to rendering times and required computing power. So artists most often faked caustics. They used textures that resemble the caustic pattern and plugged them into light materials. And to be honest, that's a fair usage. Even in large Hollywood productions, people use this approach to this very day because it simply renders faster and sometimes gives even more control. In Corona, however, we can render caustics relatively easy and without overburdening our computers. So let's go into our scene and jump straight at it. We'll show you in this lesson what can possibly go wrong, plus one trick on how to solve it. Okay, so we have our scene, and we would like to create a caustic in the foreground. We want to create a nice pattern of light at the bottom that will invoke this friendly feeling, just a kind of commercial polish. So, in order to create caustics in the scene, you obviously need to have a light source. It should be intense and powerful, but small in size. So the sun is the perfect example, but not the sun alone. You can use discs or whatever as long as it's small in size and with high intensity. So let's add Corona sun and sky here. And see how it looks in interactive. Let's adjust the exposure so the ranges are more or less okay. And so far, there's no caustics, of course. This is just a starting point. To introduce caustics to our scene, we need to go to the Render Setup and the Performance tab. And here we have Caustic Solver. We have to set it as Enable and assign all objects that will be rendered as caustics. And as I mentioned, caustics is time-consuming when it comes to rendering, so we'll try to include the bare minimum of objects. Maybe I'll move the sun a bit, so it's not in our way. Let's select the objects that are in the vicinity of the water. And now we can remove all scatters, this tree and all these plants from the selection. We won't need that. We don't need all these plants here. We won't render this as caustics. The same goes for those stones that have no direct contact with water. Basically, we go just for what we can see here, so we can select it and add it here to the included objects. We ended up with something around 110, but I can still see some unnecessary junk here, what was left of the tree. Okay, so that's around 60 now. It already looks good. Now we can turn interactive back on and see what happens. I have to unhide the sun, which I also hid. And we have this fragment of the scene isolated. We have enabled caustics globally, but generally nothing will happen yet. Just watch. If we turn it off, it's completely the same. This is because in addition to enabling caustics globally, we also need to enable it for our material. I mean, the material that causes caustics. In this case, water. Let's sample the water material. And here in the material settings in the refraction tab, we have caustics with the annotation right away that we shouldn't expect it to be done fast. Of course, let's ignore it and turn it on. We can see it's gone dark and now it's lighter again. So something happened. And to better define what we are looking at, it's handy to add a caustic render element. It will show us just the caustics alone, without the rest of the light rendering in the scene. Without any direct reflections and so on. We'll see what's going on with just the caustics. We can see that, after some time, something's going on here. It gets brighter, but we don't see what we would expect. We don't see that cool pattern that we would like to have. And many people would get discouraged now and think like, it doesn't work. I cannot set the water right. I'll do it in some other way. I'll fake it. But we'll get to that point in a moment. Let's understand why it behaves the way it does now. And I think it will be easier for us to understand the whole situation if we look at our scene from above. Let's switch to the top view in the interactive. We can see that, again, after some time, it brightens up this area. And if we look closely, we can get the impression that something is going on here. Some kind of outline, just very small. And this will be the right observation, because the caustic looks the way it does due to the scale of the noise. As I mentioned, for caustic to happen, we generally need an uneven surface. If this water were completely flat, there would be no caustic. We need some unevenness of the right scale, big enough like some waves on the water. And you can do the waves with bump, with displacement, or straight in the geometry of water. It makes no difference. Each will produce a similar caustic effect. So let's copy this material so we don't lose it. And in the new one we have assigned here, let's remove those links because this noise consists of the main noise and then there are these lower level noises and we don't need it. Let's keep it simple. If we would toss that away and leave only the main noise, we could see that something interesting is already starting to happen. We get these interesting stripes that result from the noise itself. It has a long tiling, creating long waves. If we change it a bit, we should get a more regular noise. And it's already very similar to what we would expect. The problem is solved in a way, and if we would like to be even more pronounced, we can just increase the bump. The bigger the bump, the bigger the caustics will be. At least in terms of contrast between light and dark. It looks much more natural now. We have areas of stronger caustics and weaker ones. It's generally what we would expect to see at the bottom of a swimming pool. We can also make some changes to this noise. Reduce the contrast a little. What's more, we can control the caustic scales with the noise scale. If it's a bit too dense, we can increase the noise scale. As we can see, it works pretty cool, at least until we get to the view we had. Because we have changed the bump, of course, just a few minutes ago, and the water created some reflection, and we kinda liked it. But it was fairly even then, and now it's pretty wavy. You could say a bit too much, and as if there were a strong wind. And with the reflection on the water so contrasting and irregular because of the bump, the caustics, it's not even visible underneath. It's just too distorted by the water. Something's going on here. It's just too hard to see. On the other hand, if we reduce the bump in the material to get rid of this unfortunate effect, we will lose the caustics as well. It should render out in a second. Actually, it was rendered already, but nothing happens with a bump this small. And that's the problem. The caustics looks nice from above, but with an angle like this, it's rather lousy. And we can solve this problem pretty easily with a ray switch material. A ray switch allows us to independently control global illumination, reflection, refraction, and directly visible slots. The caustic appearance on the bottom depends only on global illumination. Depends on the way the light in the scene is rendered, and we'll take advantage of that. So here, we'll attach the water material with this crude bump that creates this caustic effect, and we'll attach the other water material we had previously to the rest. I mean the calm one that couldn't create any caustic because it was too flat. And now, as we assign this material to the scene here, we'll kill two birds with one stone. We have an independent water material that we can control. Just as you can see here. We have nice reflections. It doesn't disturb perceiving the bottom. And we have a material that generates caustic. We can always come back to it if something doesn't feel right. We can change this noise and, for example, modify the styling so the caustic appears as long stripes. Maybe it's a bit too strong now. If the scale is too large, for example, we can change it by the size of individual elements. We have 100% control over its appearance, and at the same time, we have an independent control over the water's look. So this is basically a setup that's very useful for production, and there's no problem using it in our scene. This should render relatively quickly, and that's it. We hope you liked this quick shot of technical knowledge too, and we'll see you in the next lesson.